This is Honors Geometry Lesson 2.5, Reasoning Using Properties from Algebra. So the essential question is, how do you solve an equation? We all know how to solve an equation. We have already completed Algebra 1. What maybe you didn't know, that you were following properties as you were solving those equations. So we're going to solve equations, and every time we complete something, we're going to justify why we were allowed to do that. We're getting ready to start writing some geometry proofs, but in the meantime, we're just going to write some algebraic proofs. So the first property I wanted to review is called the addition property of equality. It just says if you add something to both sides of an equation, the equation is still balanced. So we've used that many times. So maybe you had a minus 3 equals 5. And you know that you would add 3 to both sides and you get a equals 8. What we did there is called the addition property of equality. We added something to both sides of a balanced equation and it's still balanced. Same thing with subtraction. Maybe if we had a plus 3 equals 5, we would subtract 3 from each side. That's called the subtraction property of equality. And I'm sure you can guess what the multiplication and division properties of equality. Multiplication says if you have, say, x over 2 equals 10, you can multiply both sides by 2 and you get x equals 20. The division property of equality, say you have 3x equals 9, divide each side by 3, x equals 3. That's called the division property of equality. And we've all used the substitution property as well. That was back when we were both first simplifying expressions. So say you had something like 2x plus 3, let x equal 5, and you would substitute it in. You would say 2 times 5 plus 3, 10 plus 3, or 13. What you use there is called the substitution property of equality. All right, let's go ahead and use what we know about algebra to write our first proof. So we're going to solve an algebraic equation, and every time we do something, we're going to justify why we were allowed to do that. Most common form of proof we're going to use is called the two-column proof, or a T-proof. On the left-hand side, you write a statement. On the right-hand side, you write the reason you're allowed to do that statement. So you always start with the given. So we have 3x minus 12 equals 7x plus 8. And the reason I know that's true is because it was given. So we write that it was given. If you were solving this, what's the next thing you would do? If I were doing, I'd probably subtract 3x from each side. I usually recommend getting your x's together, and I usually get rid of the smaller one. So you get negative 12 equals 4x plus 8. And what allowed me to do that? That's that subtraction property. Just going to abbreviate, save some time there. Then we probably want to subtract 8 from each side. And we get negative 20 equals 4x. What allowed me to subtract 8 from each side? Again, that's called the subtraction property. And last step, we would divide both sides by 4. And we would get x equals negative 5. What we did is we divided. So we'd say that was the division property. Super easy. Let's go ahead and throw in the distributive property. Everybody knows the distributive property. We're going to do the same thing. We're going to write a two-column proof, but we're going to just bump it up a little bit. Left side is the statement. Right side is the reason we're allowed to do that statement. So again, you start with your given. You usually number your columns, and we say the reason I know that's true is because it was given to me. Second step, what I would probably do is distribute that 2. So I get negative 2x minus 10 equals 12. What did I just do there? I used the distributive property. Then I probably would add 10 to both sides. What did I use? I used the addition property of equality. And I probably divide by negative 2. So I get x equals negative 11. What did I use there? I used the division property of equality. So we're just getting you used to writing proofs, but we're starting with something you know really well, which is algebra, and then we're going to switch over to geometry. I want to talk about a couple properties that maybe you're not familiar with, and maybe you do know them. First one we call is reflexive. It seems sort of silly, but we do use it a lot. It just says anything is equal to itself. It works for real numbers, 7 equals 7 or 25 equals 25. It works for segment lengths. So any segment is equal to itself. It works for angle measure. Any angle is equal to itself. Then there's something called the symmetric property, and that just means you can switch it around. I think of symmetry in art. So if A equals B, then B equals A. It works for segment lengths. It works for angles. If angle A equals B, then B equals A. Next one is called the transitive property, and I remember that by transferring. And it says if A equals B and B equals C, then A equals C. You can sort of get rid of the B in the middle and just say A equals C. Again, it works for numbers, it works for segments, or it works for angles. Okay, so anytime you see that repeated in the middle, you know you're going to use the transitive property. It's one we use a lot in proofs. Here's just a quick review of the postulates we've had so far. And we're going to use this segment addition a lot. It just says if you add two little segments together, you get a big segment. So if you have segment A, B, and segment B, C, and you add them together, you get segment AC. And the same thing with the angle addition. Just says if you add two small angles together, you get a big angle. Let's go ahead and practice a couple, and then we're going to stop for now. It says use the property to copy and complete this statement. So they want us to use substitution. We won't know what substitution is. It says if AB equals 20, that means anywhere we see an AB, we're going to replace it. We're going to substitute in a 20. Then AB plus CD equals, so again, we're going to replace that AB with a 20 and say plus CD. It's going to ask us to use the symmetric property. That's when we flip-flop it around. So it says if the measure of angle 1 equals the measure of angle 2, the symmetric property says we're allowed to say that the measure of angle 2 equals the measure of angle 1. Addition property says we can add something to both sides. So it says if AB equals CD, then we can add an EF onto both sides and we're still balanced. So we're going to say then AB plus EF equals CD plus EF. And everybody's favorite, the distributive property. We're going to distribute that 5. So we're going to go like that. So we have 5x plus 40 equals 2. And last one, distributed or transitive. Remember, that's when you can sort of get rid of this middle. And so if the measure of angle 1 equals the measure of angle 2, the measure of angle 2 equals the measure of angle 3, then you can say that the measure of angle 1 must equal the measure of angle 3. Please try the practice problems. Let me know if you have any questions. Thank you.